to Miss McGee's Honors Algebra 2 lesson of the day. Today we're going over quadratic form, and it's a continuation of what we did on Friday. Thank you.
Okay.
I'm rewatching this one.
Y'all ready now?
Yes.
All right, listen, this factoring, this is pretty easy. Your exponents are just bigger than what you're used to, okay? We're going to do the same method that we've been doing. Remember when we graphed quadratic, or when we factored quadratics, if I had something like 2x squared, how would you factor that? What multiplies to 10 but adds to -7? 5 and 2. So -5x, -2x, and then we split it in half, right? I'm running through this really fast because this is old, right? So x times 2x minus 5, and then 1, 2x minus 5. And so it factors as x minus 1, 2x minus 5. Everybody remembers how to do that, right? Yeah. We're going to use that same process, but now they're not going to be quadratics anymore. They're going to be polynomials. But we have what we call quadratic form, okay? Quadratic form means I have 3 terms. What are terms?
It's like the
Parts.
The parts of it, that's right. It could have a coefficient, a variable, an exponent, all that together, but nothing added or subtracted, just multiplied, right? That's the term. It's got to have 3 terms. The first exponent must be even. The second exponent has to be half of the first. And the third term must be a constant. Okay? If you meet those criteria, then it is in quadratic form. It may not be a quadratic, but it's quadratic form. And we can go through these same processes, these same steps to factor it. It won't be, you won't be able to do it this way if it's more than 3 terms. You may have to group it like we've been doing, but if it has 3 terms, you can factor it this way. Okay? Let me show you an example. Well, remember, before we start, we need to look for GCF to see if we can take it out. And we're going to check it. What we'll do is we'll check to see, is it a special pattern? Can I group it? If it's no and no, then is it quadratic form? Can I factor it that way? You kind of, these are all things you kind of have to run through your head as you look at. And so what we'll do is we're practicing each individual pattern, and then we'll put them all together, and you'll just have to decide what to use. All right. Could not be factored, yeah. Prime or cannot be factored. All right, and I want you to think through this problem. I'm going to pull this one out of the book because it's a little bit easier. So it would just simply say to factor it. So it doesn't look like it can be grouped, right? There's not an even number of terms. I can't really split anything up. But the first thing I want to do, my very first step in factoring is always to what? Look for a GCF, right? Does this one have a GCF?
Just a thought. You can't take 15 out of 40.
So just the 5. What does it leave? So what you can always do if you're not sure if your GCF was big enough is when you take the GCF out, if there's still another GCF left in there, there was a bigger one you could have taken, right? All right, so looking at this, I have 3 terms, right? So kind of going through my head is, can I factor it the way I know how? And it is factored by grouping, but can I factor it the way I do quadratics? Yes. Yes, it has 3 terms. The first exponent is even. The second exponent is half of that, and the last term is a constant. Okay? So then it becomes easy. I'd go through the same process. What multiplies to -90 but adds to 8?
that was way too fast for me.
10.
Wait, what did you say?
What multiplies to negative 90 but adds to 8?
Do you look at the quadratic form after you factor something?
Well, and your first step in anything you factor is to take out a GCF if there is one. There won't always be one.
5 times something.
Let me pause.
15 out.
Okay, sorry for those of you on the video. We're going to change this up just a little bit. We're going to make this 45.
Now you take. What were they doing with the original one?
They just took a GCF out of it. I don't know what they're doing. I was trying to get one from the book so that it would be a nice, easy factor for us. And come to find out.
Then now you would have to take out 15.
Oh, wait. No, well, we don't have to go back and we could just do another GCF. Now you can take 5 out of here. Yeah.
Okay, carrying on now, we're going to take a 3 out of these two. Or if you came up here originally, you could have taken a 15 out of everything. So when I take the 3 out again, I'm left with 10n to the 8 plus 3n to the 4th minus 1. All right. You can either take 15. We changed up that original problem because the problem in the book wasn't factorable after we took a GCF out. So we changed that middle term to 45 so that it would be factorable, just so you could see what a quadratic form factored looks like. So now, what multiplies to negative 10 but adds to positive 3? Positive 5 and negative 2, right? Y'all all with me? All right, so whenever I rewrite this, now here's the only difference. When you rewrite the two middle terms, they need to have the same exponent as what the original middle one had. So plus 5n squared minus 4th 2. Oh my gosh, sometimes when you go downhill, you just go all the way down, don't you? Not y'all, me. I'm saying I just started messing up and then just messed up through this whole problem. All right, so now we're going to go ahead and factor like we know how. So 15, what can you take out of the first two? 5n to the 4th, and what's left? 2n4 plus 1. Nothing to take out of those, so it's going to be 2n4 plus 1. So okay.
I put negative 2 and 4.
You put it first. That's okay. That's all right. You should come back to the same thing. Yes. So 2n to the 4th plus 1 is one of the factors, and 5n to the 4th minus 1 is another one of the factors.
Wait,
Yeah.
if you take 1 out, wouldn't that get rid of the plus 1?
There's negative.
Well, remember, if you were to distribute it back through, you got to end up with what you started with, so it's still got to hold the place there with a 1.
You just leave it like that?
And you just leave it like that because there's nothing else that can be done there. Okay. Now, you have in your toolbox of factoring here, you have all different forms to factor that we have learned. Some of them newer than others. But the whole point in factoring, rewind back to quadratics, what was the whole point in factoring? Solving for x, finding the zeros. So that is exactly what we're going to do here when we solve polynomials. Now, I know this excites y'all very much. As you solve, come on, you are going to encounter lots of things that you have to apply that you have already learned. Yay! Let me run you through solving. So, just like with quadratics, I want to make it equal 0 before I start. I want to factor completely. Anything that I can factor, I want to factor. And then I want to set the factors. Come on. What is wrong with this thing today?
It's broken. You mean every day?
Set factors equal to 0 and solve. Now, sometimes when you do this, you're going to get, because these steps look exactly the same as solving a quadratic. Here's the difference. We've got these big things. Think about if you had a sum or difference of two cubes that you were setting equal to 0. In fact, let's just do one. Let's say I had, yeah. This is when it gets fun.
I don't know after it is.
All of it's fun. It's algebra 2.
This is when it gets. That looks really weird that
But here's the thing. Whenever I solve this, right, I need to factor it. First, it already equals 0. This is a sum of two cubes. It's an easy sum of two cubes, but it's a sum of two cubes nonetheless. Same change plus. X and 3, what goes here?
X squared.
Why are you changing the signs from?
From the original.
It was just plus.
So same, change, plus. Original. The first one.
Fourth is 3.
How do you figure out?
There won't be. You won't have that with sum or difference of two cubes.
How do you get one?
Multiply these two together.
Oh, it's because 3.
What times itself 3 times gives you 27? Yes. You saw it before anybody else saw it. So the last step says set each factor equal to 0 once it's factored completely. Well, once you've done a sum or difference of two cubes, kind of put that up, you can't factor any further. So what I have to do is I have to go ahead and set equal to 0. Okay, well, this is easy. That's a one-step linear equation, right? But when I get here, now I'm rewinding back to, oh my gosh, what do I do to solve a quadratic? And we have a whole ton of different ways that we can solve a quadratic. We could factor and solve if it's factorable. This is not. We could complete the square. We could
Quadratic formula.
quadratic formula this thing, right? And that is actually going to be my best option here, because if I ever see my middle term as an odd like that, I'm probably not going to complete the square. Now, if you just want to, knock yourself out. But I'm going to go ahead and do quadratic formula. And it really should, it helped. It really should be your last resort. I'm going to continue plugging in 3 squared to b squared minus 4ac all over 2a. Uh-oh.
I'm not kidding. This has been Vietnam and back.
9 minus 36 over 2. 9 minus 36 is what? 27.
Negative 27.
So we get an I.
We get an I, and not only do we get an I, I'm out of room. I can take out 9 times 3, right? Square root of 27 is the square root of 9 times the square root of 3. So 3I root 3.
Wait, what?
That's it? You can take it. Where's the 9?
27. Remember I told you we're going to have to go back.
Right, we gotta do
9 and 3, so it'd be 3
I'll get there
root 3.
regularly.
That's okay. That's okay. I'm right there with you. What you call? Yes, because this is an imaginary, but that's a good point. Because these two solutions are imaginary, this cubic is only crossing one time. It's a good connection, Lizzie. I'm impressed. It's crossing at -3. Let's see, it's odd, it's going. So it's probably going to do something like this. It's only crossing that one time. The other two solutions are imaginary. So you're not going to see it
How did you
crossing.
know that it's crossing at -3?
That was the first solution we found.
I'm sorry.
No, don't apologize.
5 seconds behind.
It's okay. You're good. She was just saying, we were saying how 2 of the solutions are imaginary, so you won't see them when you graph. You can only find them algebraically. 3 plus 3i root 3 and 3 minus 3i root 3. Plus or minus. All right, let's do one more solving. Uno mas, uno mas. Should be what? Yeah, it should.
Because my sauce had the best flow. It like rhymes.
When you had church on, I think mine was pretty good too though. Or you should watch the video.
Tell me what to do.
Check.
Does it have a G, or does it equal 0?
Yes.
Does it have a GCF?
Can I just plug in my calculator if I'm doing it?
No, because what if they're imaginary? You won't see them.
Then they're imaginary.
Well, then you can check that. You can check.
All right, so my next question is, Marshall, how in the world am I going to factor this?
Take out the thing.
Quadratic form.
It's good job. It is quadratic form. Good job. Did somebody tell you? Who told him?
No, he was about to say quadratic formula.
No, there's not.
He said
I
quadratic
said
formula.
quadratic.
Y'all were
The
laughing
first
like
one
somebody had
positive,
whispered the
first
answer
one
to 'em.
positive, the second one's half, the third one's a constant.
Not positive, but even, but you're right. That's what you meant. That's what you meant. That's all right. All right. So I'm going to go ahead and set this up. What multiplies to 8 but adds to -6? -4 and -2, right? X to the 4th minus 4x squared minus 2x squared plus 8. Can't factor that.
Oh, wait, I thought exponents can't be negative.
And it's not a polynomial if they're negative. Yeah. All right, so x squared leaves me with x squared minus 4. I spy with my little I, difference of 2 squares. 2, x squared minus 4. So this factors as. No, you're going to be really upset because this one you would have has all real solutions. But that's okay. We need to learn to solve algebraically as well. X squared minus 4 times x squared minus 2.
Yes. So
That's
are
the
there,
difference of 2 squares. Yep.
so they're more than 2?
So what would it be?
Oh, because this is a quartic.
Correct. So what's the most number of zeros I'll have here, real zeros? If it's a quartic?
4.
4. All right, x minus 2. This is getting
yeah.
ridiculous. X plus 2. This pen. Holy crap. X squared minus 2 I can't do anything with. It's just decided it's not going to work.
You should get one of those. In 3rd grade, there's this like thing on our teacher's desk that she put her paper under and it's projected with paper.
Wait, we made this thing in art and we used that like pen body.
Is that the X just plus 0?
And then you put a sponge on the top and a wire around the sponge and then pull it through. Oh, is that the type of wire you can write on the thing? I think I have it.
All right, look, each of these is going to 0. That's a minus 2. Now, if x squared minus 2 equals 0, that means x squared equals 2, which means x equals what? Plus or minus square root of 2? There's your 2 solutions. Let me see if it'll work.
Touch the wire.
You just have to touch the wire.
And write 1, 2, that's what this all is for. Whoa. That's literally. I just made one of those. That's how I draw on my computer.
Miss me.
Yes.
You just write that as x equals plus or minus 2 and x equals plus or minus 2.
Yes. Oh my goodness.
Wait, what? Does it work?
Yeah.
After all these expensive pens,
I need one of
you get a
these.
piece of
I
wire.
made my, I need to make a lot of Q-tips too.
Wrap wire on a sponge and
Oh.
put it through.